this up, what you might want to do is make sure the square is on the left side. Set it up to these formats. This is what you have to remember. And maybe when you get your test, write this at the top. And the H always goes with the X, regardless on what side it comes with. And the Y always goes with the K. So in this case, it might be better to put your square, reflect this statement. Just switch them around. Put your square here. Now, what's the vertex coming out of this? Always with the X first. 4, negative 3. So I've got a vertex of 4, negative 3. Okay, that's my starting point. Which way is it going to open? To the right. Why did you know to the right?
Because, where the, what's it called?
4p?
Yeah.
4p is positive, right? This is equal to 4p. So what's p equal to? 2. It's a y squared, so it's going to open left or right. If p is positive, it opens to the right. If p is negative, it opens towards the negatives. So we know enough about it now to sketch. We know the vertex. Okay, you know it's opening to the right. So this is what you have so far. So with a parabola, we know the vertex. We have to find a focus and a directrix. Now, we said don't get hung up on those formulas. Instead, look at its axis of symmetry through here. So this vertex tells me 4, negative 3. I need to move 2 to the right to get my focus point. So when I move 2 to the right, what changes, my X or my Y? X, good. So I take my X value and I add 2 to it. So therefore, 6, negative 3. This is my focus point. Yes, now they use the formula, but the thing is you constantly have to worry about are you adding p to the h or adding p to the k anyway. So just take this, the focus has to be inside the parabola. The directrix is outside, can never cross your parabola. So the directrix is 2 units the opposite way. So just start with this point. If I move 2 units, I move to 2, negative 3. Just at that point. It is a line that cuts through that x value. So it is x is equal to 2. There's my directrix. You have to be able to do this. That's all that this involves. Now, we find an x and a y intercept, as we usually do with a lot of our things. This one not so bad, because it's not going to cross the y-axis, and it crosses the x just like once over here. But to find your x and your y intercept, you just set the other part of it to 0. Now, it doesn't matter which equation you use. If you develop this yourself and you want to use one of the other ones, this one we only have one, of course, but whatever step you want. So we're going to take his equation, and we're going to substitute a y of 0. 0, which gives me 3 squared is 9. I'm going to add 32 and divide by 8. So my intercept is 41/8. I don't care where it falls. I don't care where it falls. I don't care how you leave it. You don't have to give it to me in a 5 1/8. Just leave it 41/8. It's right past the 5. And see if it makes sense. If my x was at the 4 over here, could my intercept be at the 5 something? Absolutely. Doesn't that make sense? If my intercept was at the 3, would that make sense? No, because my vertex here is at the 4. My intercept has to be past the 4, doesn't it? Because it's opening to the right. So your intercept is going to help you to see if your graph is in the right place. If it's not matching what your graph does, don't leave it like that. Go back and look at maybe your sketch is off, maybe your intercept was off. Your other intercept, when x is equal to 0, says take this, put x in here. When you go to take the square root of this, you can't. So we say no real x intercepts. No real y intercepts, sorry. No real y intercepts. They're imaginary, but we don't care about imaginary. We only care about real. Questions? This is what you're looking for. Get the square to one side, find out what P is equal to. From there you can find your vertex, find your focus, find your directrix. No, I don't need, you mean these? Do you have to switch it around? No?
No, do we have to find like 8?
You will eventually. Yeah, you'll have to complete the square. But didn't you do this work already? Okay, so now, I'm going to put my square on one side. If you didn't do this, make sure you're doing this with me. Now, this is lined up with my H. This is lined up with my K. This is lined up with my 4P. That you're going to have to memorize the format of it. X minus H squared equals 4P, Y minus K. So now, what's my vertex? Good. Comes out the opposite way. Negative 3, 7. And what's P equal to? 5. If 4P is equal to 20, then P is equal to 5. So it's positive. It's an X squared. X squared can open up, can open down. When P is positive, it opens up. So far, I got this going on. I found my vertex. Let's do my graph. I know my focus comes inside, P units away, my directrix outside P units away. Sometimes it's helpful to write your vertex right here so you can see it. Because we sketch, I can't remember sometimes how far up that Y I went. I'm at 5. Sometimes I need to see it there. So now, 5 units up and down. Which one's changing, the X or the Y? The Y. So I'm going to keep my negative 3, and I'm going to add 5 to my 7. There's my focus. Now my directrix says drop down below this because you can't go through this. I'm going to drop down 5. This point right here is negative 3, 2. I just want a X equal line through the, I want a Y equals line through this, not an X equals line through this. I want a Y equals 2 in this case. I don't want to cut through. Sorry about that. I don't want to cut through my parabola. I want a Y equals line. Make sure you give me X equals Y equals on your directrix. If you just say negative 2, it's just a number. You've got to give me an equation of a line. And intercepts, plug in X is 0, Y is 0 into these. You can do that part. So when X is 0, I've got, when Y is 0, we'll do the Y is 0. I come back here, when Y is 0, it brings you to here. Say, I can't take the square root of a negative number. No real x-intercepts, and we clearly see it doesn't pass through the x-axis. When I do my x equals 0, I resolve this, and yeah, this goes in maybe like a little bit more than 6. So does that make sense that I'm a little bit more than 7? 6 wouldn't make sense, but 7 does, right? A little bit more than 7. 7.45? Yeah. So I'm a little past the 7, and that would have to make sense, because here's my 7. 6 would be over here. So 7.45, it's wide. It's just a wide parabola, because look at this. It's a fairly large number. So it's a wide parabola. The one time where you have to do your intercepts before you do your sketch is not so much here, but when it crosses too close to your origin. Or is it going to stay on the left side of the origin or the right side of the origin? Because I don't know how wide it's going to be. Stop me if you're not comfortable with this. We're good? Okay. All right, in this part, first, we notice we have to complete the square. When you have to complete the square, look for the guy that's squared. Get anything with that variable to one side. get everybody else to the other side, which it already is, right? So now you're going to leave a space to complete your square. If you add to one side, you have to add to the other side. So what is half of 8? And what is 4 squared? 16. If I add it to that side, I add it to this side. So 8y, and combine these guys, 24. I still need to look like this for p y minus k. So I just take this out of here. So factor out an 8. Okay, so now what's your vertex? -4, -3. Good. This guy now is equal to 4p. What's p equal to? 2. Which way is it going to open? Up. Okay, so now we can sketch this. Here's my vertex. P is going to move up. It's going to change to y. So I keep my x for my focus point. And I add 2 to -3. Brings me to -1. That's my focus point. I drop down 2. So now my y is at a -5. And there's my directrix. Now, this is the one I'm talking about. You might want to do your intercepts before you sketch this. Because if I'm sketching and I say -4, -3, I'll probably make my parabola look like this. But my y-intercept is going to bring me over here somewhere. So sometimes it's easier to put your vertex, figure out where you're opening up or down, and then do your intercepts first. If you come down here and do your intercepts, at least your y-intercept will help you. Your y-intercept turns out to be at -1. So I can't possibly cross right here. I know I have to cross right here. So I know that's a little bit wider. And then you can do your x later. At least catch your y. If your y is positive, it will bring you above it, and you won't hit that x-axis on the right side anyway. So kind of figure from there. Because you want your sketch to be close to what you're doing. It's just that in the parabola, we don't know how wide we should go. That 8 is making us go a little wider than our normal parabolas. And then you can do the other one, the x-intercept. When you get down here, don't forget, you have to resolve this guy. Radical 4, radical 6. So 4 plus or minus 2 radical 6. But if you think of 24, it's close to 5. So -4 plus 5 puts you right to the positive side. -4 minus 5, well, you know you're going to be in the negatives anyway. Everybody do this? Good? Okay. Okay. How many of you didn't do this one? Did everybody do this one? I was going to stop and have, okay. So now we know what to do. Stop and do this one. Do you have to do 2 different? You have to do one for the x-intercepts when y is 0, and one for the y-intercepts when x is 0. Now, here's the thing. All of these are the same. So what my thing to you guys out there was, you don't have to use this one. If you decide that x is 0 and you want to use this guy right here, and x is 0, it says 0 equals -4y minus 9. Solve that one. They're all equivalent equations because you didn't change it, you just transformed it.
Okay, but if I use that one for the y, can I use that same one for x?
You can use whatever you like. I wouldn't use that same one for x, only because if you're left with this, well, I guess if you want to be left with -9, if this is factorable, which I doubt, you're going to have to use some kind of quadratic or something else. You might as well use the one that we already completed the square on. But that's just me. Bathroom?
Yeah.
Yes. So we good with this? Can everybody do this?
Do we have, for the intercepts, we have to give a coordinate, or can we just say?
If you just give me y equals x equal, I'm okay with that too. Because we know the other part's 0, but if you're just giving it to me as a coordinate, that I tend to write them like that. All right, find the equation. So now, we got to start with your graph, because I have no idea where this is opening, no clue how to start. So they give me a piece of information. I like to start with my vertex. So my vertex is 4, 5. Then they told me my focus is 4, 7. Now, doesn't my parabola have to come around my focus point? So therefore, I know I'm opening this way. I'm opening up. So x opens up and down. So I start like this. Well, I've got h and k, so I can plug those in. X minus 4 squared equals 4p y minus 5. Now, all I have to do is resolve p. Can I find p by that diagram? P is what? P is 2. P is the distance from here to here. P is 2. And P is positive because it opened up. So now,
Minus 4 squared equals 8.
yep. Yep. And you just leave it like that. If it happens to be opening down, P is negative.
We have to find the intercepts for that too?
No, you didn't. You don't have to do them on your thing. I just don't ask me why I did it. I probably just lifted this out of the book. Okay, go by what your diagram says. So we're good with this? Okay. And last one. Okay, you're given a little bit more this time. You're given a focus, 4, 3. This is my focus point, not my vertex, and my directrix. And x equals negative 2. Now, somewhere halfway in between there, what am I going to find between my directrix and my focus? The vertex. So if I know this x, I'm going to go like this. I'm just going to make a line of symmetry. I need my x value because it's moving across my x's. I take my negative 2 and my 4, and I take the average. So this gives me 2 divided by 2. This gives me 1. So over here, when x is 1, this is my vertex. X is 1, what is y? 3. It's right on this line. There's my vertex. There's my HK. So I know also it can never open up over my directrix, right? So it's going to have to open this way. When it opens left or right, is it an x squared or a y squared? Y squared. So I start like this. I plug in what I know. I know my vertex. This is my H. This is my K. Okay, and now all I have to do is find P. P is the distance from either one of these guys. So I like this one better. 4 minus 1, P is 3. Is P positive or negative? Positive, because I'm opening to the right. So I plug P in here. And so then I get y minus 3 squared equals 12, x minus 1. I subtract P is the distance from the directrix to the vertex, or the directrix to the, or the focus to the vertex. So it was easier just to say 4 minus 1 and get 3. Now, just keep track of, is it opening positive? Then I know it's positive. If it's opening negative, there's a formula whenever you find P, and that is P is equal to F minus V, wherever the thing is, because I didn't write it here. P is equal to F minus V. But rather than worry about which way you're subtracting, go right off your diagram. If it's opening to the left, then P is negative. If it's opening to the right, then P is positive. No, you didn't have to find the intercepts on this one either. Are we comfortable? Let me just take a look.